So looking at another example with limits and doing this by direct substitution first, trying that. We have an example, the limit as x is approaching 1 of x raised to the negative 1 minus 1, all in the numerator, and then all over x minus 1. Again, we're going to have the same problem I see when we go in here, when we plug in 1 wherever we see an x. We're going to get, again, 0 over 0, which is that indeterminate form and doesn't tell us anything, right? If I plug in 1 in here, raise that to the negative 1 power minus 1, all over 1 minus 1. So this is equal to 0 over 0. Okay, so recall really quickly that this x raised to the negative 1 power, we can rewrite this to have a positive exponent. Since it's in the numerator, we can think of this as over 1. We can bring it down to the denominator to make it positive. So recall this is the same thing as 1 over x. So let's go back and let's rewrite our limit with 1 over x instead of x to the negative 1 power. So we have the limit here as x is approaching 1 of 1 over x minus 1 all over x minus 1. So really that didn't change anything in the fact that when I go back in here and plug in 1, I'm still getting 0 over 0. But if you have a complex fraction, so this is another case where you have fractions within fractions, how you should get rid of that or manipulate it so it's not an indeterminate form anymore is clear the fractions within the fraction. And so I can do that by multiplying by the LCD of the fractions within, which is just x. I can multiply the numerator by x all over the denominator as an x. So when we distribute this, that fraction goes away. And so bringing down the limit, because I haven't taken the limit yet, we have x times 1 over x, which is 1, minus 1 times x, which is x, all over, distributing this. Do I want to distribute? Well, let's just do it. X squared minus x. Okay, so I notice again, and I shouldn't have distributed, but sometimes we don't see that right away. If we go back in here and we plug in 1, wherever we see an x in here, I'm having the same problem because this gives me 1 minus 1, which is 0, all over 1 squared minus 1, which is also 0. So let me go back and rewrite this limit by pulling out an x in the denominator. So we have 1 minus x in the numerator, and the denominator is x all times x minus 1. Still the problem, we still have 0 over 0 when we plug in 1 there. But notice these factors are almost identical. This 1 minus x factor and this x minus 1 factor. They're off is by a negative 1. So let's factor out a negative 1 from the numerator, and then we'll have identical factors in the numerator and denominator that we can cancel. So I have the limit as x is approaching 1, pulling out the negative 1. I'm going to rewrite it as the same thing. This is negative 1 plus x, or x minus 1, all over x times x minus 1. So now those factors cancel. And now we can, when we go in and do our direct substitution, we get a number and we don't get 0 over 0 anymore. So we have negative 1 in the numerator all over, plugging in 1 for x, 1. So that limit is equal to 1. Negative 1. So when we're looking at a graph of this, notice that our function is not defined at x equals 1. That makes our denominator 0. It's not in our domain, but graphically, if we were looking at this graphing this function, as x is getting closer and closer to 1, your y value is getting closer and closer to -1.